So for today's lesson, we're going to be looking at multiplying and dividing with complex numbers. And in order to divide with complex numbers, we need something called the complex conjugate. And what that does is it changes the sign of the imaginary part. So if our imaginary number is a plus bi, the conjugate is a minus bi. All right, so we're going to be looking at, as I said, multiplication and division with complex numbers. Multiplying complex numbers is similar to multiplying binomials, and dividing complex numbers is similar to rationalizing a denominator in a radical expression. Before we see how that works, we need to look at powers of I. And I need to apologize because I evaluated I squared incorrectly on yesterday's lesson. So remember, I equals -1. For I squared, what I should have done was literally take a -1 and squared it, as opposed to multiplying it by itself. So what happens when you take the square root of -1 and square it is the square root and the square are inverse operations, so they cancel each other out. I squared is -1. So when we get I cubed, we can split that up as I times I squared. Well, I squared is -1 times I cubed is equal to -I. I to the fourth is the same thing as I squared times I squared, which is -1 times -1. So I to the fourth is +1. I squared is -1. I to the fifth equals I to the fourth times I. Well, I to the fourth is 1, so I to the fifth is I. I to the sixth is I to the fourth times I squared. I to the fourth is 1, and I squared is -1, which is the same thing as I squared. I to the seventh is I to the fourth times I cubed. I to the fourth is 1, I cubed is -I. And then I to the eighth equals I to the fourth times I to the fourth, which is 1 times 1, which is the same thing as I to the fourth. So what happens is, for every multiple of 4 that your exponent is, the pattern repeats. So to evaluate something like I to the 27th, we need to figure out what multiple of 4 can we split that up as. Well, the highest multiple of 4 that goes into 27 is 24. And there's 3 left over. So I to the 27th is the same thing as I cubed, because I to the 24th is 1 because it's a multiple of 4. I cubed is the same thing as -I. So to simplify I to the 27th, it's the same thing as -I. All right, so multiplying with complex numbers. So the first example we have is just a basic distributive property. So 4i times 2 is 8i. 4i times 2i is 8i squared, but I squared is -1. So we have 8i minus 8. If you want to write that in standard form, the real part comes first, so it's -8 plus 8i. For part B, we have distributive property. So 2 times -5 is -10. 2 times -3i is -6i. I times -5 is -5i. And I times -3i is -3i squared. So we have -10 as our real part. -6i minus 5i is -11i. I squared is -1, so we have -3 times -1, which is +3. Adding that 3 to the -10, we get -7 minus 11i. For part C, we have distributive property again. The square means multiply it by itself. So we've got 2 plus I times the square root of 3 times 2 plus I times the square root of 3. Distributing, 2 times 2 is 4. 2 times times I times the square root of 3 is 2I squared root of 3. Same thing here, 2I times the square root of 3. And then here, the square root of 3 times the square root of 3 is 3 times I squared. So simplifying this, remember the I squared is negative 1, so that becomes negative 3. So I'm going to combine that with my 4 to get 1. And then my two terms in the middle are like terms because we have the same number under the radical. So 2I plus 2I is 4I times the square root of 3. When you're combining like terms with radicals, treat it like a variable. So if that were x, when we add x and x, we don't get x squared, we just add the coefficients. So same thing with the radical, we don't change the number under the radical. And another example on the last one, this time we've got some subtraction, so we've got 6 times 5 gives us 30. 6 times negative 4i is negative 24i. Negative 4i times 5 is negative 20i. And negative 4i times negative 4i is positive 16i squared. But that I squared is a negative 1, so this is really negative 16. 30 minus 16 is 40. And combining my terms in the middle, I get negative 44i. Right, so that's multiplying with complex numbers. This last page we're going to look at is dividing with complex numbers. The way that we do that is we multiply by the complex conjugate. Remember, the complex conjugate is the opposite of the imaginary part. And what we're looking at is getting I out of the denominator. So we're looking at the complex conjugate of the denominator. Whatever you do to the denominator, you do to the numerator. So we multiply the numerator by the same thing, by the complex conjugate of the denominator. So in order to multiply these, I need to use my distributive property. So for the numerator, I've got the 2 times 1 is 2. 2 times 3i is 6i. 5i times 1 is 5i. And 5i times 3i is 15i squared. In the denominator, I'll show you the long way for the first example, and then I'll show you the shortcut for the second example. So we've got 1 times 1 is 1. 1 times 3i is 3i. Negative 3i times 1 is negative 3i. And negative 3i times 3i is negative 9i squared. So in the numerator, combining my like terms and simplifying, remember this last term is really a negative 15 with that I squared. 2 minus 15 is negative 13 plus 11i. And in the denominator, what happens is our I terms cancel. And then this negative 9i squared is really a positive 9 because I squared is negative 1. So 1 plus 9 is 10. To write this in standard form, we would just divide. So our real part is negative 13 tenths. And our imaginary part is 11 tenths I. Standard form, there's no fraction bar. You can have fractions for the real number and the imaginary part, but they're not combined. So hopefully for this shortcut you guys noticed that the I terms canceled. So when we did this part of the distributive property, they canceled each other out. So I'm just going to skip that with my second example. Also, instead of, when I multiply these pieces, instead of writing it as a negative 9i squared, I'm going to go ahead and multiply that by a negative 1 right away. So see if you can follow some of these shortcuts on my second example. Again, multiply by the complex conjugate of the denominator. So it becomes 2 minus 5i. And you do the same thing in the numerator. In the numerator, I have to do my full distributive property, because none of those pieces will cancel. So negative 3 times 2 is negative 6. Negative 3 times negative 5i is positive 15i. Negative 4i times 2 is negative 8i. And negative 4i times negative 5i would give me a positive 20i squared. But I squared is negative 1, so it's really a negative 20. In the denominator, 2 times 2 is 4. Those middle terms are going to cancel. 5 times 5i times negative 5i is negative 25i squared. the I squared makes it a positive 25. So when I simplify my numerator, I have negative 26 plus 7i. And in my denominator, I have 29. Oops. So again, to write that in standard form, I'm going to split that up into two fractions, negative 26 29ths plus 7 29ths I. And the last example here is just I in the denominator. So all we need to do is multiply by I. In the numerator, remember using your distributive property, 1 times I, and then the negative 4I times I would give me a negative 4I squared. And in the denominator, I have I squared. So simplifying this, it turns into I plus 4 in the numerator. In the denominator, it's a negative 1. I'm going to kind of simplify this backwards in order to put it in standard form, because the real part comes first. So 4 times divided by negative 1 is negative 4. And then the imaginary part, minus I. And it looks like I forgot the slide with the assignment, so if you are a freshman and you won't be in class tomorrow, look for the assignment under December 12th, Wednesday, December 12th on my class jump page. I'll post it there.